what exactly is so special about generative AI? So we went through deep learning neural network last time. We talked about how animal brain, we have different layers of neurons, uh, and there are simple neuron process visual cues, but then there are intermediate neuron process, say, a combination of geometries, and then there are hard neuron process even high level informations. That's neural network. Generative AI is also built on the neural network. But what's different between the generative AI, the current trend in comparison to the, let's say, classical machine learning is really this word generative. Okay, I'm trying to see what I can. Classical machine learning versus generative AI. They will all likely use neural networks. Right? So this is what they have in common. Um, but what the classical AI often do is mainly two things. One is called classification, and the other one is called regression. It's two type of models. Classification basically put the labels, and regression is basically put the numbers there. That's the two main tasks the classical machine learning uh, method. Uh, Now the so-called generative AI, the key is really they're going to also try to classify regression. Those methods still there, but they are going to create new things, create not new, but I'm going to put a quote on it. Exactly what's new actually is kind of subjective. Create a new content. That's what the generative AI, I guess if you probably everybody have heard about ChatGPT now. So that's what so it can seem to create almost like human-like product, like essays, answering questions, or even taking exams. That's what it does. So that's a bit different from the classical approach. The classify labels like a cat, a traffic light. It is important, but especially for autonomous driving. I mean, if we can uh, distinguish pedestrian versus a vehicle, it is very important for safety in driving, like traffic light, red light, green light, orange light, and those are very important in practice. But that's not enough, right? So, and the create this generative AI, they're going to seem to help human to accomplish some new tasks. That's what the generative AI does. So, okay, so generative AI is also based on the neural network. In general, there's a few three major types of a generative AI model. One is so-called a generative adversary neural network. That there's another one called variational autoencoders, and then there's another recent one so-called transformers models. So I'm going to first basically go over the three one, focusing on just the generative adversary neural gains, and then transformer. I'll probably skip the variational autoencoder for just to focus on the most, I guess, popular ones. So focusing on the gains basically is what? Generative adversary that networks. Right, so it's the keyword here is adversary. So, oh, sorry, there are still people in the waiting room. I'm going to assign some of you as a co-host. That way, if there are new people in the waiting room, and some of you can just help them join. So, sorry, I'm going to, and there are people turn their camera on, so I'm going to reward those people as co-hosts. This, so, let me see, co-host. Okay, good enough. Enough co-host. So in this game model, it's adversary usually means compete. If you have an adversary, you have to fight with it. That's actually literally this means. So in a game model, there's two part, and these two parts going to fight against each other or work with each other, if you want, depending how you view it. One of them is what we can call that generator. Another one we can call that the evaluator, or the in the classical way that it is called a discriminator. Let's just use that word for the time being. And so what that discriminator, for example, let's just use the example to generate say a picture of cat. The generator, so the discriminator can tell a cat from other images. Then generator going to create new images of cats. And the discriminator going to tell whether that's the real cat or it's a fake and not a cat. So the generator basically generates random things, new things. The discriminator going to tell whether that is a cat or not. Through this process, the generator going to learn how to improve the so-called the model parameters to generate more realistic cat images in the way that the discriminator cannot even tell whether it's fake or real. So the discriminator job we learned last time, that's basically classical machine learning, right? So we can use that to classify a real cat or a fake cat or cartoon cat, right? So and there's you can see there's some stuffed animal. It look like a cat, but it's not a real cat, right? So the job is basically to tell is that a real cat or fake cat? Is it real or fake? The generator, the job is basically try to generate a fake one, but it's almost as good as the real one, so that the discriminator cannot even tell. The generator job is is going to generate a fake object, but the fake object is so close to the real one, the discriminator actually will classify it, actually call it a real one. That's basically is what this idea is, a generative adversary neural network. So it has two kind of neural network, a generator and discriminator. And this discriminator is basically the classical one. But the generator one actually have different way to generate use. And in fact, it can use variational autoencoder. It could other way, it's so-called a diffusion method. There are different various kind of we can use to do the generator, but the basic idea is this. We have a generator to propose new things, and then we have a discriminator to say whether it's a real or not. If we think about this, what is this process? This is almost like what? For those who have taken biology, what is this? Can someone put in the chat window, what exactly is this process? This is because I study a lot about computational biology things. So this is basically the evolution process. If you think about it, that's by the way, this is just my own perspective on this. The evolution process. In the evolution, there's a lot of what? Mutations and what? Recombination. Those are where the new species or new trait come from. And then what is that discriminator? Is going to tell what's going to stay or not. That's basically is selection, right? So in evolution, you basically have this, again, those two processes. One is so-called a generator. It create a new trait, new species through mutation, recombination. But in the end, it's what that selection process going to say you stay, the other one not stay. This is basically the idea of evolution in a way. Of course, this is what in biology, but in AI, people come up with this. So this is this is AI. And this is evolution. So this is the idea is not really new. I mean, that's how I become us today. So we have all this genetic material come. In fact, all of us got one copy from mom, one copy from dad, but not exact because those genetic makeup actually resorted. We only get half of that. Right? So it's also mutation recombination. That's one of the major source of generating new species, new individuals, actually new species as well. Of course, you can argue what exactly the new species. That's a different matter, though. So, but this is basically what the general adversary neural network means. So, okay, as this step, okay. So that's basically is the code. It's actually public. Besides, this is what majority of the code are written by ChatGPT, so it's really not a secret. So this is actually also a very old example using TensorFlow. The most recent one now using the PyTorch and the so-called Hugging Face. But because this TensorFlow has been written for a while, those are, I guess, well tested. So in this case, I asked ChatGPT to write again example using the MNIST. Remember, the MNIST is just handwritten digits. And, oh, it's not here. So let me see. But MNIST is just the handwritten digits, like 501, and then that's basically the MNIST data set. So here we first write a generator. This generator basically try to generate new handwriting images. And then we also have a discriminator. That discriminator basically going to tell whether that is a real number or not a number. And this process basically is to create new handwriting as real, as close as to the human handwriting. That's basically this the example trying to do. And so it has this, it first gave a generator and then gave a discriminator. This basically is a classification model. It's like the example actually we kind of went through last time as well, but also very quick. That's basically is this one, MNIST neural network demo. That's a classification. So so we have this generator, discriminator, and then we basically how is this model going to? It's going to try to train. Let a generator has a generate image as close as possible to what the real image which will be classified as real image is. So that's the objective. And you can actually see the generator start from really nothing. It just generates from random noise. Very impressive. This is actually is that basically it start from random noise and then try to generate a realistic real image. So yeah, it's kind of really impressive how AI can do. If you really get into the detail to realize this is really come from nothing. It's just random noise, white noise. So so the neural network training often can go through what they call epochs. Each epoch means it goes through finish all the training data set and then goes, that's called one epoch. Usually it takes many epoch. In this case, I only did a 3 epoch just to save time. In fact, each epoch probably take half an hour or something. So I got 3, save the result, and didn't do anything. But you can actually see initially those random images just look like a noise. It's just noise. And then I after 2 more epochs, actually it doesn't look like something. Like this is close to a 0. I don't know what this it still doesn't look like handwritten digits, but it's much better than this random noise now. So it's just impressively just 3 rounds. It actually generates something like this. Yeah. Uh, I didn't wait to try for 50. But you can, if you have time, you can let it run and see after 50, maybe it does give more realistic handwritten digit now. Uh, uh, I mean, the original image will be like those, right? So initially it's basically random noise. Like initially it's just random noise. Here it's just random noise. After one epoch, it start to have some. After one round of training, it start have something. After just two rounds of training, it actually seem to start have some patterns there. It's very impressive how the AI can work. So, yeah. So that's basically is the general adversary learning neural network. This is you can actually try to play with this. This should be run free on the Google Colab. So even if you have a slow laptop, it's still okay because it's not running on your own laptop. It's actually running in the Google Cloud. So if you click on that, it should take you there. Actually, I have this already open. So uh, yeah, it takes a while to run, and then make sure you save the image. So if you let it run. So okay, so then the next, so this is general advisory neural network. Uh, you may say, well, this is just handwritten digit, but we can actually use this for many other things. We can actually generate very realistic human image. You probably have seen there's a lot of fake video of like Tom Hanks. There's a fake Tom Hanks video and of him like playing golf or doing some art things. But people who publish that video make it very explicit. This is a fake video generated by AI. It's just to bring people's attention to what AI can do. So uh, and this is in this example, we are just trying to mimic human handwriting of digits. So it's not really controversial, I guess. So you can actually see the implication of this. If you can generate something generate something fake, but very close to a real object. Right. So okay. So the next one is actually more topic will be more interesting will be the transformer. So I need to go back to my iPad. So the word transformer